Can OpenAI Whisper and a MEMS microphone translate languages into English?
तो ये हिंदी में मैं ऑडियो दे रहा हूँ। देखते हैं क्या इसे हिंदी से अंग्रेजी में अनुवाद किया जा सकता है या नहीं।
If you have been following this audio series, you already know that we covered the Whisper introduction, basic code walkthrough, and the complete MEMS microphone setup with ESP32 in our playlist. And just like I promised in the last video, today is the multilingual test of both transcription and translation. Will the model detect correct languages? And will the translation be reliable? Let's find out. Namaste and welcome to Avinashi Tech. I'm going to go ahead and speak the same message in multiple languages and see how Whisper handles the transcription part. Let's start with the easy one first, English.
So we have finally completed 1000 subscribers on our YouTube channel. Thank you everybody for making this happen.
File saved, inference is running. Okay, this is interesting. This time we have got 43% English, 38% Norwegian Nynorsk, and somehow 11.5% Latin. Looking at the transcript, it's mostly correct. The only thing it struggled with was 1000 subscribers. To be fair, that's something even I struggled with for a while. Alright, moving on. Let's try Hindi.
तो आखिरकार हमने अपने YouTube चैनल पर 1000 सब्सक्राइबर पार कर लिया। आप सभी के सहयोग के लिए तहे दिल से धन्यवाद।
File saved, inference starts. Boom. 93% Hindi and about 4% Urdu. The transcript. Some words are correct with the right spacing, but some have wrong spacing. Some words are completely off, but honestly, this is still okay. Especially when you remember that English dominates the training data and current model we are using is also the smaller one. Alright, next up, Gujarati. And fair warning, my Gujarati isn't exactly award winning.
અમારા YouTube ચેનલનો સબસ્ક્રાઇબરનો આંકડો 1000 પાર થઈ ગયું છે. તમારા સહયોગ માટે ખૂબ ખૂબ આભાર.
Saved, inference running. Alright, now this is fun. It thinks Hindi is 39%, Gujarati barely crosses 3%, and Bengali shows up at around 12% out of nowhere. But hey, confusion on Gujarati and Bengali together is nothing new. The transcript captures a bit of the essence of what I just said, but grammatically it's broken. Definitely not accurate. Last language for this test, a lesser known one. OpenAI hasn't explicitly trained for it, but I really wanted to give it a shot. Mathili, the language of Mithila.
हमर YouTube चैनल पर 1000 सब्सक्राइबर पार भ गेलै। एहि के लेल हम अहाँ सब गोटा के खूब खूब आभार प्रकट करै छी।
And yep, strong tilt toward Hindi again at 58%, followed by Bengali at around 10%. The transcript, as expected, completely wrong. Alright, so that wraps up our transcription test. Definitely try out your own native language and see what happens. Do drop us a comment about the result you got. Now let's test the translate feature. For that, I will be using the transcribe function method which was discussed in the previous video and add translate task as a param. I've also set a macro flag on top which I will enable, then save it and jump back to the terminal. Running the script and I'll speak in Hindi again.
तो ये हिंदी में मैं ऑडियो दे रहा हूँ। देखते हैं क्या इसे हिंदी से अंग्रेजी में अनुवाद किया जा सकता है या नहीं।
You might notice a warning, FP16 not supported on CPU. Don't worry about it, that just means we are running on a CPU instead of a GPU, and that is totally fine. And look at this, timestamp 0 to 13 seconds, showing the translated English text for that particular time frame. Then at the bottom you get the full translation in one shot. If your audio is longer, these timestamp chunks become super helpful. And if you don't care about these segments, then just set verbose equal to false and you will only see the final translation. Okay, as for the translation, yeah, that is pretty much what I said in Hindi. It's good enough. Alright, for the next set of tests, we are stepping beyond Hindi and trying out Spanish and French. Now I'll be using audio from my phone through Google Translate because first, I don't actually speak Spanish or French, and second, I definitely don't want a copyright strike by using someone else's audio, even if it is for engineering purposes. Let's start with Spanish. I'll type the message in English first. All set. Let's hear how it sounds in Spanish.
Este es un audio en español. Veamos si se puede traducir al inglés o no.
Now, I'm going to move the phone a few inches away just to simulate a more realistic recording scenario and play it again while running the script.
Este es un audio en español. Veamos si se puede traducir al inglés o no.
Alright, language detected Spanish. Take a look at the timestamp around the 0 to 20 second mark. The translation is almost spot on. That's impressive. Now let's bring French into the picture. Same process as before. Type the English sentence, generate the French audio, and listen to it once.
Il s'agit d'un enregistrement audio en français. Voyons si cela peut être traduit en anglais.
Great. Now let's run the script and play it back again.
Il s'agit d'un enregistrement audio en français. Voyons si cela peut être traduit en anglais.
Alright, detected French and the translation honestly good enough to clearly understand the message. But let's push it a little further. I'm going to play the same French audio a couple more times to see if the translation stays consistent. And we are waiting for the translation. Okay, that's interesting. This time audio was translated as video. Everything else looks perfectly fine though. Let's try that one last time. There we go. The context is preserved and the translation is correct again. But notice something important here. The words don't match exactly every single time the inference runs. And that's completely normal. Speech models like this don't just memorize sentences, they interpret them. So slight variations are actually a sign that the model is understanding the meaning rather than blindly converting speech into text. Now, quick conclusion. Sometimes the detected language, transcript, or translation might look completely bogus. When that happens, set the parameter temperature to 0. Make sure your MEMS mic audio is actually audible. Play the recorded wave file. Try to be in a less noisy environment, and yes, don't speak too softly. All of this makes the model's job harder. Also, if you try the online Whisper API, the transcription is better than what we witnessed. Remember, we tested the small model, not the large one, and other than that, there are pre-processing differences in API-based test and offline one. And one more thing, we recorded using the ICS43434 MEMS mic, streaming over UART to the PC. Different microphone, especially built-in laptop mics, can produce very different results. With that, we have officially tested our MEMS microphone and an offline speech-to-text model running locally on a PC. Pretty good already, but like I said earlier, you know what would be even cooler? If we test ESP32 itself doing keyword spotting without sending I2S data to a computer at all. And that's exactly where TensorFlow Lite enters the story. So in the next video, keep your seatbelts fastened because this audio ride is about to get a lot more exciting as we take a closer look at TF Lite. Until then, thanks a ton for watching. If you enjoyed this video, hit like, share it, and subscribe if you are feeling the vibe. See you in the next one. And this is Avinashi Tech signing off.